A very good morning, students. We are in our regular class lecture, and the subject is sedimentology. And this is lecture number 4, and the topic of discussion is the rocks of mechanical origin. And for this topic, refer the books: The Introduction to Sedimentology by S. M. Sengupta, Sedimentology and Stratigraphy by Gary Nichols. Okay, the rocks of mechanical origin. So the sedimentary particles of mechanical origin, which is also called as the terrigenous origin, are classified according to the grain size. Okay, the particles of larger than 2 millimeter constitute the gravel, which is also called as rudite in Latin, and the particles of grain size between 2 millimeter to 1 by 16 millimeter constitute the sand size particle, which is also called as arenaceous in Latin, and the particles of finer than 1 by 16 millimeter constitute the silt and clay, which is also called as the lutite in Latin. Okay, and accordingly, the sediment rocks of mechanical origin are broadly classified into three categories, that is the rudaceous, this is arenaceous, and lutaceous, which is also called as the argillaceous. Okay, so the mechanical origin of sedimentary rocks are broadly categorized into these three categories, which is solely based on the grain size. Okay, so if the grain size is more than 2 millimeter, it is called as an Rudaceous rock. If it is in the range of 2 by 1 by 16 millimeter, this is called as arenaceous rock. Okay, and if it is less than 1 by 16 millimeter, then it is called as argillaceous rock. Okay, and this video is mainly focused on the Rudaceous rock. Okay, so let us see the classification of Rudaceous rocks. The Rudaceous sedimentary rocks, the unconsolidated sediments coarser than 2 millimeter are grouped under the term gravel. Okay, so the gravel is a general term which is equivalent to the Rudaceous sediments. Okay, which is actually unconsolidated. The indurated gravel are called as conglomerate, while the particle consisting of the conglomerate are essentially rounded. So if this gravel is consisting of mostly or mainly of rounded grains, and if it is converted into rock, then it is called as a conglomerate, and if it is having angular grains, then it is called as a breccia. The term rubble is applied to an assemblage of loose angular fragments of gravel size. Okay, so this is called as a rubble, which is having angular grains of say gravel in size. The breccia need not be sedimentary origin only. Say for example, breccias can be formed in the fault zone, which is called as a fault breccia, right? And it is also formed somewhere in the volcanic origin, which is formed like a volcanic bomb consisting of the agglomerates, which is called as a agglomerate. Okay, so breccias can be of sedimentary origin, sometimes fault origin, even sometime at a volcanic origin. Like other sedimentary rocks of mechanical origin, the space between the framework grain of a conglomerate is filled by finite particles, and these fine particles constitute the matrix of the rock. The gravel and sand fragment can combine in various proportions to produce a conglomerate, and the resulting rock is named accordingly. Okay, so just like other sediment rocks, the gap between the grains have been filled by the finer particles, and the ratio between the coarse grain and the fine grain can be used to name that rock. Okay, conglomerates may be classified either purely descriptive, which is called as a cherty conglomerate or limestone conglomerate, where the classification is mainly based on the composition of the grain. Okay, and according to the mode of the origin, which can be called as a fluvial origin, glacial origin, say fluvial conglomerate and glacial conglomerate. And in the comprehensive genetic classification proposed by Pettyjohn 1975, conglomerates are grouped into four major categories, which are geologically meaningful, that is epiclastic, pyroclastic, cataclastic, and meteoric. So there are so many classifications, but we used to follow Pettyjohn classification because this classification is quite impressive and important in terms of geological meaningful. Okay, so they are epiclastic, pyroclastic, cataclastic, and meteoric. But the epiclastic conglomerates are the commonest of all conglomerate. These consist of gravels of terrigenous origin. Okay, the conglomerates of fluvial origin as also those generated on a beaches and by wave action are all of these types. So when the grains are formed, okay, due to the erosion, transportation, and deposition of this size, this comes under the epiclastic conglomerate. Okay, so the intra-formational conglomerate, which is the first type in the epiclastic conglomerate, which are also epiclastic or composed of clasts derived within the basin. Okay, the shale pebbles produced out of mud cracks are good example of intra-formational conglomerates, but this process may be more complicated. Okay, so there are conglomerates which has been formed within a basin, which may be not transferred for a longer distance, and the composition may be of a shale, right, of shale size sediments. Extra formation of epiclastic conglomerates includes oligomectic, tetromectic, and diametic. Okay, so what is oligomectic? Where oligomectic conglomerate consists of pebbles of homogeneous composition, whereas petromectic, or even sometimes called as polymectic conglomerate, consists of pebbles of varied rock type. Okay, so if the conglomerate having grains of same minerals, it is called as oligomectic. If it is constitution of different minerals or different rock bases, then it is called as polymectic or petromectic. Diametric conglomerates are characteristic by high proportion of matrix. These may be glacial, say tills or tillites, or non-glacial, that is called as tilloids origin. The pebble mudstone, that is argillite, are also included in this group. Conglomerate found in the alluvial fan deposits are good example of tilloids. Okay, so the diametric is a term which is given to conglomerate which is consisting of more higher proportion of matrix, whereas oligomectic and polymectic or higher proportion of pebble sized grain, but it is having different in composition. If it is having different in composition, it is called as petromectic. If it is of homogeneous composition, it is called as oligomectic. Okay, other important types includes pyroclastic conglomerates of volcanic origin, cataclastic produced by earth movement, and meteoric produced by meteoric impact. Okay, so these are the different classifications. So and here is a table which is proposed by Pettyjohn in 1975, where you can see the types of conglomerate, name of the conglomerate, description, and origin. Okay, so we'll just recall one after that as we had discussed earlier. The first one is the epiclastic conglomerate, which is formed due to erosion, transportation, and deposition. Okay, when this process is required for the formation of conglomerate, it comes under the epiclastic. Okay, when it is of pyroclastic, then it is originated by heat, which is called as like volcanic eruption, where cataclastic is formed when there is a plate movement or tectonic activities. Okay, and meteoric is formed when there is a meteoric impact. Okay, so these are the different types of Rudaceous rock, and this epiclastic is further classified into oligomectic, polymectic, diamectic, and intra-formation conglomerate. But oligomectic means the conglomerate consisting of same composition, which is derived from vein quartz or monometallic rock, mostly which is formed in a fluvial or wave or beach conglomerate. Okay, so this is how the oligomectic forms. And polymectic is of consisting of varying type of matrix. Okay, which is derived from the rock of varying composition, and this is also formed in a fluvial, wave, or beach conglomerate. But diamectic, as we mentioned earlier, which is having a higher proportion of matrix, have been classified into three, which is conglomerate, argillite, tillites, and tilloids. Where conglomerate argillites are laminated argillite with ice rafted pebbles, which is formed as valves. Okay, and tillites, which is having high matrix conglomerate with striated facets, pentagonal boulders. Okay, which is formed as a glacial origin, and tilloids, which is formed in a chaotic assemblage of non-glacial boulders in a muddy matrix, and this is formed in a non-glacial environments where like subaqueous gravity flow of an alluvial fan, you can expect this type of tilloids deposit. And as you know, the intra formation conglomerates are something which is formed within a basin, which is having composition of say mud, shaly pebble, intraclast, and which is formed due to the temporary phase of subaerial erosion. Okay, as you know, pyroclastic, which is a volcanic breccia, or which is also called as agglomerates, where blocks of previously deposited volcanic material has been blasted out due to a volcanic eruption, and the origin is of volcanic. Where cataclastic forms the breccia, which is angular fragment, crushed pieces of fault gorge, slug and slide blocks, etc. This is how it is formed, and it is formed by stumping, folding, faulting, etc. And the last one is the meteoric, which is formed by the impact breccia, which is an effect of shock recognizable, and which is formed due to the meteoric impact. Okay, is that clear? So if you have any doubt, you just mention in the comment section. We will discuss in the class later. Thank you.